Hey, good morning. It is April 6th, the day we were originally intended to go back to school, but we're not going back to school. So we're here and we're on remote learning, and it's week 2 of remote learning, and we're still talking about ecosystems. Actually, we're just starting with ecosystems. So, you know what, let's enjoy some ecosystems. And I've got on the screen the energy flow in ecosystems. And really, ecosystems, or the study of how organisms interact with the biotic and abiotic factors within an ecosystem, really talks about energy. And if we're talking about energy, then we're looking about how we trace those things through. Now, some of this might seem somewhat familiar. So as I kind of go through this relatively quickly, take a look and make sure that this makes a lot of sense to you. So I'm going to scroll this down. Nope, I'm going to back that up and scroll down the view so you can actually see what we've got here in regards to a primary producer, an herbivore, and some carnivores, which are all the different things that we had talked about in the last video, and how this kind of goes in a nice linear fashion from algae to the flag fish to the largemouth bass to the anahinga and the alligator. And now we're obviously looking at a food chain. It's connected linearly, and that's going to be something that is in an aquatic ecosystem, obviously. So when we talk about food chains, and sorry, let me scroll that up so you can see it a little bit better. Here's your food chain, and it's just a little zoom in on what that image was on the bottom. Boom, going on. And if we go ahead and advance that screen, we've got, ooh, it's a food web. And all of this should seem somewhat familiar to you. You've probably heard some of this stuff before. This shouldn't be terribly new or any kind of huge revolution for you, but nice to review in terms of food webs. And when we look at food webs, we can look at the way in which, again, the energy is flowing through the ecosystem. So the web takes into account all of the aspects of how different things are interconnected. The energy comes from the primary producers, which are going to get their energy directly from the sun, comes down to the primary producers, and the primary producers then allow it to kind of flow up into larger organisms. In this instance, we've got the anahinga and the vulture that are at the apex there, the vulture being the decomposer, which is going to break down every last little piece of dead and dying material that exists. The apex predator in this particular food web is the alligator. So you can see that it's going to consume most of those things there. On the other side of the food web, you've got a bobcat. The anahinga is on the other side, which is also going to be one of those apex predators that exists within there. Great. Let's advance. When we take this here, let me scroll so you can see. Nope, let's do it the other way. It's a little touchy when it wants to actually scroll that up. There we go. The trophic levels and ecological pyramids. And if you want to pause this as you get this, I will make a funny pause face. All right, and then you can go ahead and jot down any notes that you need from trophic levels or ecological pyramid. It's going to be one of those things that you're going to have to execute and discuss as a question topic at the end of this video. I will post it to your Google Classroom. I think the key here is, if we could put in a key here, let's see, my pointer will work, is that the 10% rule here. Looking here at that 10% rule, double check number 5. It's pretty important. It's really, I'm going to look you right in the eyeballs. There you go. Double check number 5 there. And then number 6, obviously, is that we're moving from level to level to level. I need to scroll this down. You can pause it there if you'd like. Let me scroll this down so that you can see the bullet point number 7, which gives you a definition of what an ecological pyramid truly is. And we get the relative amounts of energy that gets moved from trophic level to trophic level. So if at any point you need to back that up and look through those things, you can double check that, pause it, and then jot any notes that you might need to be able to accomplish. Okay, let me advance. Here is an actual ecological pyramid and what it would kind of look like. And notice, if you would, right over here where heat is being lost. During each trophic level, for as we move from energy level to energy level, from primary producers to first level consumers, et cetera, heat is lost out, and that's the heat that is generated through cellular respiration. We didn't discuss heat as a byproduct, but I think it's kind of an obvious thing. That's why, as organisms that maintain our own core body temperatures, where is that heat coming from? It's through the combustion process and the energy that's going to be moving. So as we go from energy level to energy level, we're also losing heat into the atmosphere. We have to get all of the primary energy either by breaking it down with chemosynthesis or from the light, which is photosynthesis. Flashback. Woo, 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 woo. Yeah. And so if we do it in some numbers, you can actually see how those ecological pyramids kind of make that function. All right. Pausing at any time. Once again, having to grab the right cursor and mouse to be able to give you that note piece there. And so we get energy, biomass, or just general number of organisms. And those are the three different types of pyramids that we can see as they move from trophic level to trophic level. I'm going to advance through this really quickly to try to keep this video at a relatively short amount of time. Pause as needed. Here are those three different types, and you can't see the pyramid of biomass very well. I will scroll down so you can see it. Let's look at the energy one, which is kind of similar to what, well, except identical to the one we just looked at. Pyramid of numbers. Obviously, at the base of your pyramid, you're going to see lots and lots and lots and lots of organisms, and then we're going to start getting smaller and smaller and smaller, and that's kind of the way the pyramid works. And then you have small numbers of high-level consumers, tertiary level consumers, which are going to be the ones that are at the top, and there aren't going to be that many of them for a given area. Pyramids really do take into account one ecosystem. So if we were to take into account all of the large predatory birds, which is in the pyramid of numbers, then there's going to be more of them. But in one ecosystem, to support that one predatory hawk, you're going to need that many snakes, rodents, et cetera, to feed the rodent or feed the snakes. You're going to need down those smaller organisms, and then that's how much grass within that ecosystem. So it's kind of in there. Let me scroll down there so you can see the biomass pyramid there, and then that's going to give you some actual numbers in terms of within the percentages, following that rule of 10%, that if you grow 500 grams of grain, that will then yield for you 500 grams of chicken. And then that will give you 50 grams of human tissue. And that's kind of how that is there, which is why we need to eat a lot more chicken, if you like chicken, than the chicken has to eat. So if you were to skip that level and not eat the chicken, we could make an argument for vegetarianism at this point, where you're not losing all of that heat from trophic level to trophic level. You're not losing that extra 90% of energy is gone from the grain to the chicken, and then another 90% is lost into the human tissue. So if you skip down and you then just eat the grains, then you've eliminated an entire trophic level within that biomass pyramid, and you're probably going to be doing a better job in terms of environmentalism. Let's just face it. All right, I'm at 8 minutes. Let me just double check. I think there's one more here. Nope, this is taking us into cycles of matter. So I'm going to pause us right here. This will be the next video. Thank you very much, ladies and gentlemen. Well done. Look in your Google Classroom for a comprehension question that goes with this video.